Hello, everyone. Welcome to lecture 13 on introductory statistics. Now, in today's lecture, we're going to move on to section 3 in chapter 5, the binomial distribution. Now, before we talk about the binomial distribution, we have to talk about this so-called Bernoulli trial. So what is a Bernoulli trial? So a Bernoulli trial is a random experiment with only two possible outcomes. Okay, so with only two possible outcomes. Now, we will say one of the outcomes is termed success and the other is a failure. Okay, so if the probability of success is denoted by P, then the probability of failure is going to be 1 minus P. Okay, now just think about the flip a coin, the random experiment of flip a coin, right? So you may got a head or tail, right? There are just two possible outcomes, right? So if we say getting a head is a success, then the other one, getting a tail, will be called a failure. Now the probability of success, sorry, probability of getting ahead is B, then the probability of failure, which means the probability of getting a tail, is going to be 1 minus P. So then anyway, so this is the definition of a Bernoulli trial. Now, one thing you have to be careful is the word success in the definition here is arbitrary. All right, it does not necessarily represent something good. Now, for instance, you want to check whether you go for a screening test of COVID-19, right? So say if you got a positive test result, let's say that is success, right? Then it's a negative test result, then that's a failure. Okay, so the success here doesn't always represent something good. It can be represent something that is not good. Okay, so now, but it is usually means what? Success usually means the outcome that is counted. So that's the outcome that is of interest. So you want to know the number of positive cases of COVID. So that is something we count, right? So that is usually what that is called the success. Okay, so here are some examples. Flip a coin. So two possible outcomes, right? So check randomly selected adult is a smoker or not, right? Is a smoker or not? So it is two possible outcomes. Now is random flight departs on time or late? Two possible outcomes, right? So therefore these are the Bernoulli trials. Now let's consider a random experiment consisting of n Bernoulli trials. All right, and with the same probability of success, P. And we're interested in the number of successes among them. Okay, so in this one, okay, so this is going to be preparing the so-called binomial distribution. Just think about that. If you flip a coin for 10 times, right? If you flip a coin for 10 times, now you're interested in the number of heads among these 10 trials, right? So the number of successes now tends to be what? Binomial distribution. Now let's consider this definition. Consider n identical and independent Bernoulli trials with probability of success P. All right, if you flip a coin, fair coin, right? So it's always independent and also identical. The probability of success is the same. Let X be the number of successes in these n trials, right? X is the number of successes. Okay, so then X is called the binomial random variable with the parameters n and p. The probability distribution of X is called the binomial distribution with parameters n and p and denoted by X, B, and P. Okay, All right, this is the binomial distribution. Now consider this example. We want to determine whether the random variable x below is a binomial random variable. If it is not, explain why. If it is, specify the values of its parameters. Let's consider A. Consider the procedure of flipping a fair coin for 8 times, and that x be the number of heads obtained. Okay, so for this one, this is a fair coin, so it is always what? It is always, the probability of success is always 1/2. Okay, so, and also flip coins, they are going to be independent of each other. Okay, so x is a number of heads. Okay, number of heads. Heads here is a success, right? Because that's the outcome that we're counting, right? We're counting. So therefore, x thus is a binomial distribution, right? X is a binomial distribution, and the number, these values of parameter here, n equals what? Flip a coin 8 times, right? 8. Okay, so that's the total number of trials, Bernoulli trials. And P is what? Fair coin, so it is 1/2. Probability of getting ahead is 1/2. And this one, X, okay, does has a binomial distribution. The parameter is 8, and this is 1/2. Okay. B, a box contains 30 chips, 15 black and 15 white. 8 chips are randomly selected with replacement. Let X be the number of black chips among these 8 selected chips. Okay, so it is with replacement. All right, be careful here. It is with replacement. So every time it is always the case that we have 15 black and 15 white chips in this box, right? It's always the same because it's with replacement. So the probability of getting the black chip is always 1/2. So probability of success is 1/2. And we are trying to do that, what? 8 selected ones. So n equals 8. And they're independent because it is with replacement, right? So they're independent. Hence, we have x as a binomial distribution with parameter n is 8 and p is 1/2. Okay. C, box contains 13 chips. 30 chips, 6 are black and 24 are white. 8 chips is are randomly selected without replacement. Okay, without a replacement, be careful here, is without replacement. X will be the number of black chips among these 8 selected chips. So for this one, since it's without replacement, so they are not independent. Okay, they're not independent. So you get one, and you do not place it back, right? So the probability between trials affects each other. Okay, so no, this one X is no, it is they are independent. The trials are dependent. They're not independent because it's without a replacement. So no. The multiple choice test has 15 questions. 8 of them have 4 choices, and the other 7 of them have 5 choices. It is known that among these choices provided, there is one and only one correct choice. The student answers these choices by randomly selecting one from the choices provided that exceed the number of correct answers the students get on the exam, on the test. So this one is, I know there are 12, 15 questions, so n is 15. Now, however, 8 of them have 4 choices. For these 8 questions, so we will have the probability of getting the correct one is going to be 1/4. Now, however, for these 7 of them have 5 choices, so we have P2 is what? 1/5. Now you can see that the probability of success are not the same, right? You have 8 of them have probability of success is 1/4. 7 of them have probability of success is 1/5. So their probability of success among trials are different. So no. right? No, because the probability of success are different, are not the same. Now, for binomial distribution, we have the following theorem for their probability distributions. Okay, so if X has a binomial distribution with parameters n and p, the possible values of X will be 0, 1, da, da, da. Okay, sorry, this is da, 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 0, 1 through n. Okay, so number of successes, it can be 0, right? So all of them are failures. So in that case, X can be 0. It can also be 1, only 1 success, and 2, and then n. So all of them results in success. So the probability values are given below. Okay, so this is the formula we have for the probability values. Okay, P of X equals this one. Here, X can be 0, 1, 2, till n. Now this one is the untruth X. Okay, so untruth X. Untruth X is a notation. All right, it's n factorial over x factorial times n minus 1 factorial. Okay. Now, calculation-wise, this can be very complicated. Just think about this one, right? So you need to find the value for factorial, 3 factorials, and then the power, and then 1 minus p to the another power. So that's going to be really hard to calculate directly. However, there is this for binomial distribution. There are many calculators have built-in functions to find probabilities regarding to a binomial distribution. Now, this instruction is based on T83 or 84. If you have other versions of the calculator, you can Google it. I believe there for many calculators, there are built-in functions for binomial. Okay, so for T83 or 84, so there are 2 types of probabilities that can be directly found using the calculator. Now, one of them is to find the probability for X equals X. Okay, here capital X has a binomial distribution with parameter n and p. All right, so now to find the probability for X equals a given value, then we can use what? The second, go to distree, go to binorm, be careful, PDF. All right, binorm PDF, I input npx and enter. Now, another tab, the other tab is the probability for X less or equal than X. Okay, so less or equal than X, we use the function binorm CDF. All right, it's second, go to distree, go to binorm CDF. Now, N, P, and then X, and enter. Okay, so now these are the 2 types of probabilities that can be directly found using the calculator. Okay, so for other types of probabilities, we need to do some transformation. Okay, let's consider this example. All right, here X has a binomial distribution with n equals 10, p is 0.75. Here n is 10, p equals 0.75. So now the first one, px equals 6. So as you can see, this is the first tab, right? So the probability for the random variable to be a given specific value. Okay, that's the first one. So what we're going to do is we're going to use the TID3 or D4. All right, so you follow this one second, go to distree, and go to binomial. Be careful, PDF. You select the binomial PDF, and then it is n is 10. So I'm going to write down the this one. All right, so binorm PDF, and 10 as our n. P is 0.75, and X here is the value of interest. For this one is 6. And then you go click on enter. So you should have got this one is 0.146. Okay, this can be directly found using the calculator. Now for the second as well, right? So for the second is X less or equal than 6. So we can use the calculator, but be careful, it is what? binorm CDF, right? Cumulative distribution function, 10.75 and 6. And then you should get this one use 0.224. Yeah, 0.224. 3. Okay, so for 3, you see that this is a probability that it cannot be found directly using either this calculator. So what shall we do? So we are going to transform this probability into an expression for which we can use a calculator. Okay, so as you know, X is a binomial distribution. It's a number of successes. It's a count. So for the probability that this count to be less than 6, it's the same as what? It's the same as the probability for X is less or equal than 5. Right? The number of successes is less than 6. It's the same as the number of successes is less or equal than 5. Okay, now we see that this is of the second type, right? Less or equal than 5. So this one equals what? Equal to binorm CDF, okay, 10.75, and what? Here is a 5, right? So this one equals 0.078. Okay, very good. So as you can see, we cannot find this probability directly. However, we can transform it to an expression for which we can use the calculator, right? When X less than 6 is the same as what? The probability for X less or equal than 5. And then we can go from there. Now then, what about the fourth one? X greater than 6. So how to find the probability for X to be greater than 6? Now this one, we can use what? The complement rule. All right, so this is the event that the number of successes is greater than 6. So the complement event is what? Is going to be 1 minus the probability of the complement event is going to be X less or equal than 6, right? So as you can see, using the complement rule, we know that the probability for the number of successes to be greater than 6 is 1 minus the probability for X is at most 6, right? So therefore, this equals 1 minus the binorm CDF 10.75 and 6. It's 1 minus 0.146 equals 224, right? Here is 224. So it equals 0.776. Okay. Now for last one is again we want to find out the probability for X greater or equal than 6. So we are going to use the complement again. So it's X less than 6, right? Strictly less than 6. So this one equals what? Equals 1 minus the probability for X less or equal than 5. All right, so basically this is 3, right? So for 3, X less than 6 is less or equal than 5. So it equals 1 minus the binorm CDF 10.75 and 5. So it is 1 minus what? 0.078. So it's 0.922. Okay, so that's how we do this. All right. Now consider this example. Assume that 17% of the population are under 20 years old. Let X be the number of people in a group of these from this. Okay, so who are under 20? Who are under 20? All right, sorry, who are under 20. Now, A, use the formula to construct a probability distribution table, and B, find the probabilities of X less or equal than 2 and this greater than 2, and find the mean, right? So let's just try to find this ones using the formula. So how can we find the probabilities? Okay, so firstly, we need to, this X is given here is a number of people in a group of 5 randomly selected individuals, right? So it's randomly selected for each of these individual 17%, all right? It's a probability that it's under 20 is 0.17. Okay, so we will know that X has a binomial distribution with parameter N is 5, and P is what? P is 0.17. Okay, so this is the distribution of X. And then we can calculate the probability for this one, right? So now the possible values of X are what? It can be 0, right? So none of them is under 20, right? None of them can be 1, exactly 1, 2, 3, 4, and 5. So 5 means what? All of them are under 20, right? So these are the possible values of X. Then we need to find all the probability values, right? P of X. Now how to find that? Using this formula. Okay, so let's see what we can do. Now here is P of 0. So you just plug in the formula and you find this one. Okay, similarly for P of 1, and find this one, P2, P3, P4, P5. You can find that. And then the probability distribution can be constructed here, right? So X, P of X, 0, 1, 2, 3, 4, 5, and the probabilities. Now, the summation is 1 up to a rounding error. This is what? Part A. So we verified that we say that this is a binomial distribution. The parameters NP is 0.17, possible values from 0 to 5. And also we found all these probability values. Okay, and then we construct the probability distribution table, okay, like what we did right in A. Now, of course, we can also use the calculator, right? We can use a calculator to find these values, right? P of 0, the binomial PDF is this one, so, and P1, P2, and so on. This should be P5, sorry, P5, should be 5. Okay, so we've got all these ones using the calculator as well. And this is a part A. Now for part B, we want to find the probability X less or equal than 2, less or equal than 2. As you can see from the table here, less or equal than 2, that means what? These is 3, right? It can be 0 or 1 or 2. So less or equal than 2, it is the P of 0 plus this one. So we find this is 0.9625, right? So now the event for X greater than 3, right? So greater, greater than 3. Now greater than 3 means what? Means either 4 or 5, right? So P4 plus P5, that is given here. Now we can also use the calculator to find these values. Now less or equal than 2, binomial CDF, and we do get the same result as you can see here, right? So the result is the same. Now, similarly for X greater than 3, we can use the calculator. It is 1 minus the probability X less or equal than 3 is 1 minus that. It is this one. So we got the same result here as well. Right, this is our part B. All right, we can find the probabilities of these two events. Okay, so one is X less or equal than 2, the other is X greater than 3. Now, part C is we want to find the mean. Okay, remember how to find the mean given the probability distribution table. So we use the formula what? Mu equals the summation X P of X, right? X times P of X. So this product, then take the summation, right? So that's what we did. Mu equals the expectation, equals the summation of the product, and put them together. You can find that this is 0.8497. Now, of course, this is up to a rounding error. this actual running error. Now you can see that this for binomial distribution, in order to calculate the mean, all right, so you can see that we need to take, well, using the definition, right? So we need to do a lot of work, right? Times to find all the products and take the summation, right? So it's very, very long process. No, this is just the mean. So what about the variance? Right? In order to find the variance, you need to find another product, and then we're using the formula, so that's going to be even longer. Now, fortunately, for binomial distributions, we have the following theorem. Okay, so which you can easily, all right, give the formula for the mean, the variance, and standard deviation. So if X is a binomial distribution with parameters n and p, then the mean, variance, and standard deviation, all right, can be found using the following formulas. Mean is simply n times p. Variance is n times p times 1 minus p. And the standard deviation is simply the square root of the variance is square root of np times 1 minus p. Okay, so if we're using these ones, all right, it can be we can easily find the mean, the variance, and the standard deviation. For instance, consider this example, find the mean, variance, and standard deviation of the binomial random variable in example 5.10. All right, in the last example, as we know, X has a binomial distribution with what here, right? So is okay, so n is a 5, p is a 0.17, right? N is a 5, p is 5, this is 0.17. Okay, so we know that X is a binomial distribution with parameters n is 5, p is 1.17. Now we want to find the mean. So what is going to be the mean? Mean here is n p equals n is 5, p is 0.17. So what is that? This is 0.85, right? 0.85. Okay, so you just multiply them together, and you got that. And the variance sigma square is np 1 minus p. All right, so you just plug in the value times 0.17 times 1 minus 0.17, and then this one equals what? This one equals 0.705. Okay, so, and then the standard deviation is simply the square root of np 1 minus p. All right, so equals square root of 5 times 0.17 times 1 minus 0.17. Okay, so this one equals 0.840. Okay, so you can see that using the formulas, right? So we can easily find the mean, the variance, and the standard deviation. So you better memorize these formulas. All right. Now consider another example here. An English-speaking tourist visits a city in which 20% of the population speaks English. The tourist wants to ask for direction to a museum and talks to 8 local people along the street randomly in English. Let X be the number of people among these 8 local people who can speak English. Now, A, okay, so we want to find the probability distribution of X. Now you need to specify the values of the associated parameters. B, find the probability that at least one of these 8 local people can speak English. That is the probability for X greater or equal than 1. C is find the mean and standard deviation, right? So let's just do this, right? So what is the probability distribution of X? So as we know, it is 8 local people randomly. So they're independent. And we know that 20% of the population speaks English. So X has a binomial distribution with a parameter n is 8, p is 0.2. Okay, so that's part A. B, the probability that at least one speaks English. So that's a probability for X greater or equal than 1. So it equals what? Greater or equal than 1, right? So at least 1 speaks English. So let's use the complement rule. It's better to use the complement rule, right? So, oh, that means what? The complement event is going to be none of them speaks English. In other words, the probability for x should be equal to 0, right? So x equal to 0. So none of them speaks English. So it's 1 minus the probability that none of them speaks English. So it equals what? 1 minus, okay, p of 0, as we know, you can use the formula binorm PDF, okay? So here 8, okay, that's 0.2 and 0, okay? So you can find that. Well, you may find this one equals what? This one equals, plug in all the values. You should find this one is 0.832. All right, 0.832. All right, this is C, find the mean. All right, what is the mean? The mean is simply n times the p is 8 times 0.2, so it's 1.6. And the standard deviation, be careful, it's a standard deviation. So it is what? NP 1 minus p. So a square root of 8 times 0.2 times 1 minus 0.2. So this one equals what? Equals 1.131. Okay, 1.131. Okay, so that is how we do this one, right? So we firstly specify the distribution of x, and then based on the distribution and the calculator, right, we can find the probabilities and also the mean and the standard deviation easily. Okay, all right, that's all for this this one. So I will see you in the next one. Thank you.